Assalamu alaikum warahmatullahi wabarakatuh. So today we will discuss about a new kind of circuit which is known as the integrator by using operational amplifier. So integrator. So we are going to discuss about integrator. So what is integrator actually? It is used to integrate. It is used to integrate the voltage waveform, we can say. So you will be giving some input signal which is a voltage waveform basically, and it will be passed through the integrator. Okay, it is a special kind of circuit, and you will get some output which is nothing but the integral of input. Okay, and you know this sign for the integration, integral 0 to t for the input voltage. So you know that this sign is for the integration. So how we can perform this integration? So integration means what? You know that the integration means what? Means the repeated sum actually. So integration means what? It is nothing but the repeated sum. The repeated sum. Okay, that means that if you have some values, for example, you have some value 0, 2, 5, 4, etc., discrete values, then maybe 2, some 3, like this. Suppose you are integrating from, let's say this is equal to t equal to 0, and this is the value at some time t is equal to, say, capital T. Okay, then the integral from 0 to t is nothing but here the sum of all the values from 0 to t. That means that the sum of all the values from 0 to t. So what is the integral of this? This is 0 plus 2 plus 5, and this is your t here. So 5 plus 4 plus 5 plus 2. So this is the answer for the integral. So this is nothing but now summation. Why it is a summation? It is because these are all the discrete set of values. Discrete set of values. But if you have a continuous set of values, for example, you have a function. So suppose you have a continuous set of values. Suppose you have a function, for example, a function like this from 0 to t, and this is 1. Okay, so since we are talking about the voltage, we will talk about this is 1 volt. Now integral of this 1 volt from 0 to, let's say this is this is 0 and this is t. So integral 0 to t 1 volt dt is nothing but, you will get t, and the limits from 0 to t is nothing but t. So what is the meaning of this? The integral will be like this. The integral voltage will go to t. That means it is the nothing but the area. So at this point the value will be t. Okay, the value will be t. So this is the integral of the input. And what is your V in? V in was a constant. So you have a constant as shown in the blue color, and you have an integral as shown in the red color, like this. So if you integrate a constant value, you will get a straight line which is a slope. Okay, that means always you know a constant is represented as some a. Then what is the integral of a constant? With respect to time, if you are integrating, then you will get a into t. Now if you are putting a limit from 0 to t, then a constant is a, and you know this is a constant. So a constant into dt, which is equal to a into t. You put the limit 0 to t, you will get a into t minus 0, which is nothing but A into T. So if you have a constant, I just want to tell you that if you have a constant, say this is a constant and this is the time and this is the constant, then the integral of that constant will be like, it will be like this. Okay, so this is the integral. So integral is always having a form A into T. So this part is a constant, it will not change, and this is a straight line, always increasing. Now if you have a straight line, now another example, if you have a straight line something like this, okay, now you integrate it, that means this is in the form of A into T. Now if you integrate it, integral of A into T is equal to A into T square by 2. That means this becomes second degree and this was first degree and this is now second degree. So the degree is increasing. So it will be like this, you will get something like this. So this is A by 2 into T square. Okay, so this is the integral of A into T. So this is what happening. Suppose this is a voltage and this is your let's say this is your V in, and if you are passing this V in through an integrator circuit, you will get some V out, and this V out will be having this form as shown in red color. It will be having this form. Okay, it will be like this. So we will see some examples. Anyway, before that we will see first about the circuit diagram. So you want to store something, or you want to add something more and more, then you have to use a capacitor, because the capacitor will store this charge. So this is minus and this is plus. Of course we will be grounding here, and we have a R, and we have some C, and this is your V in, okay, and this is your V out, and this is your capacitor, and this circuit is nothing but the integrator. Why it is an integrator, we will see now. We will first do the circuit analysis. So this is an integrator circuit. Okay, if you give some voltage, for example, if you give some pulse voltage like this, then you will get some output, something as an integral of the input. Suppose this is T and this is a constant A, then you will get this maximum value as A into T. So this is your maximum value A into T, and this is your maximum value A into T. Okay, so the graph will be having a form AT. So this is the time axis and this is your V out, and I told you this is V in. Okay, now if you are giving some input like this, this is your input. Suppose you have an input in the form of A into T, then you will get the output in the form, let's say this is T and this is your V in. Now you will get the output in the form something like integral, it's second degree, then it's A into T square by 2. Okay, so this is what you are going to get the output. But how? Okay, that we will see now. So you have an integrator like this, and this is your R and this is your V in. Now you have a capacitor and you have V out and C. Now we will see this voltage. I told you this is ground, so it's 0 volt. So this voltage also will be 0 volt because of the negative feedback from the capacitor. Now we will use the circuit theory. Okay, let us assume that all the currents are moving away from the junction I1, I2 and I3. So I1 plus I2 plus I3 is equal to 0. What is I1? I1 is 0 minus V in divided by R, plus what is I2? It is current going into the op amp, it is 0 ampere. And what is I3? It is the current through the capacitor. but the capacitor is having some voltage. At this point the voltage is actually 0 volt, and at this point the voltage is V out. Okay, and I am assuming a current direction which is going like this. This is my assumption only. Okay, so what is my I3? So before that I just want to tell you what is the equation for the current through the capacitor. It is Q equal to CV, so dq by dt equal to C into dV by dt. But so this is nothing but I is equal to C into dV by dt. That V means what? The voltage across the capacitor. But voltage across the capacitor is nothing but, I am talking about a current which is moving in this direction as shown like this. That means that I have a high voltage here and a low voltage here. This is my assumption. Okay, then only the current will move like this. But my assumption is like the current is moving in this direction and this is I3. So I will take the voltage at this point as VA and this is my VB. So my VC will be VA minus VB, because I am assuming that the current is flowing from A to B. That's why. So this is 0 minus V out, because VA is 0 and VB is V out. So what is the VC? VC is equal to minus V out. So what will be my I or the IC, the current through the capacitor? So IC will be equal to C into minus dV out by dt. So this become C into minus dV out by dt. So this total is equal to 0. So why I am getting here now, minus V in by R is equal to C into dV out by dt, right? I can take this guy to the right side. Now I will get dV out by dt is equal to minus 1 by RC into V in. Okay, so my V in may be a function of time, so I will not just use V in. I will just assume that this is a function of time, V in of t. If I assume V in is a function of time, my output is also a function of time. So this is also a function of time. Everything is a function of time. Okay, so now I will rewrite this equation. dV out of t by dt is equal to minus 1 by RC into V in of t into V in of t. So how can I find my output? My output will be nothing but V out is equal to minus 1 by RC into integral V in of t into dt. So from which limit, actually whatever the points I am considering, up to that point I have to integrate. So 0 to t. So it is not good to put the same variable in here, here and here. It is not so good idea. So for mathematical convenience, I will just write like this. It's nothing but V in of tau d tau. So this is the output of the integrator. So you see here that I can easily find the output. Okay, now this is my output actually for the integrator. Now you know that okay, fine, this is good. Now you see here how we can find, we will do one problem. After that I will give you some more examples. Okay, we will do one problem. So the problem is, let me check the question now. Okay, determine. So you see here we have got the integrator now. So determine the rate of change of okay, the question is determine the rate of change of the output voltage in response to the input wave. Okay, the rate of change of output voltage in response to the input square wave shown in the figure. Okay, the output voltage is initially 0. The pulse width to the input square waveform shown in the figure. Okay, the output voltage is initially 0 and the pulse width is given as 200 microsecond. Okay, it is given as 200 microsecond. Now this is the question. You are giving a voltage from minus 2.5 to 2.5. It is a pulse which is changing from minus 2.5 to 2.5, and again it is going like this, and the width of this pulse is given as 200 microsecond, and you have a circuit which is an integrator. It is an integrator R, and minus plus, and you are giving this input V in. This is your V in anyway, and you are giving here to the capacitor. That's it. Okay, so this is the circuit. Now you have to find what is the rate of change of output, but you know that the rate of change of output is nothing but, I am going to write the answer, dV out by dt, because we have from the previous formula that it is nothing but minus 1 by RC into V in of t. It is minus 1 by R into C into V in of t. So this is nothing but minus 1 by RC into V in of t. This is equal to minus of what is the input? The input is 2.5 volt divided by R is equal to 10 kilo ohm. Okay, multiplied with 0.01. Actually this is given R is given as 10 kilo ohm and this is given as 0.01 microfarad. So 0.01 microfarad. So you will get this as minus 25 kilovolt per second, or this is nothing but minus 25 millivolt per microsecond. Okay, this is the answer for the first part. Actually this is the part A of the question. Now you have to draw the output also. This part B is to draw the output. So what is the output? Actually you know that you know how to find the output voltage, right? Okay, now we have the pulse like this. So what is the V out? V out is nothing but minus 1 by RC into integral of input voltage, and input voltage is V in of t, V in of tau d tau, from integral 0 to the time period whatever you want. Okay, but here the time period it is given as 200 microsecond. Okay, it is not the time period anyway, it is nothing but t by 2 for the first half cycle. So for the first half cycle, because your input is like this, it's going from minus 2.5 to 2.5 and it will stay there for 200 microsecond. So you have to integrate for 200 microsecond. So this is nothing but minus 1 by 10 kilo ohm into 0.01 microfarad into, this is actually 2.5 volt. If you integrate it, you will get this tau. Then you have to put the limit between 0 to 200 microsecond. Okay, because we are putting the limit from 0 to 200 microsecond, because it's starting from 0 and it's going till 200. So what it will be? So you have to multiply. So the answer is you will get this answer as the 5 volt if you calculate this. That means that your output will go from not 5 volt, it is minus 5 volt. There will be a negative sign. So you can see that your output will be going from 0 volt to minus 5 volt when this pulse reaches this point. Okay, now you see, so in the last part of the question I didn't write anything about the negative input, because when you give a positive input, this is plus 2.5. Similarly, dV out by dt, when you give, now this is, I can say this part is for plus 2.5 as the input. Similarly, I can write it for minus 2.5 also, minus 2.5, then I will get it as the answer as plus 25 millivolt per microsecond. Why I am getting, when I give the negative input, you see that when I give the negative input, I will get the positive output. When I give the positive input, I will get the negative output, because the input is connected to the inverting terminal, that's why. Okay, now you see my input is going down now. When the input goes down, my output will be going to 0, right? 0, because you see here that this is minus 5, now it will charge to plus 5. So this is for the first positive half cycle, then for the, that is for the positive half cycle. Now V out for the negative half cycle will be exactly 5 volt, right? It will give you 5 volt, but it will be a positive number, but it will not go to 5 volt. Why? Because this is just showing the charging of the capacitor. Now the capacitor is charged to, now the capacitor is charged to minus 5. Minus 5 means your V out is minus 5, like this. Okay, so this is your V in. Now the capacitor is charged to minus 5 volt. Now during the negative half cycle, the capacitor, the negative half cycle, the maximum charging of discharging, the maximum charging position of the capacitor is 5 volt anyway during the negative half cycle. Okay, so what will happen when the input goes to negative? Your capacitor will start charging or discharging, you can say, in the opposite direction, so that it will actually, because it is staying at the same time up to 200 microsecond again. So this duration is also 200 microsecond. So the capacitor will completely discharged. Now again in the next cycle, your capacitor will charge to minus 5. Like this it will continue. So I hope this is clear to you. So initially the charge across the capacitor was 0 volt, then the capacitor charged to minus 5, then some plus 5 voltage will be get added to the capacitor because of the integration, because of this minus 2.5 volt input, because if you give minus 2.5 volt, the capacitor will try to charge towards 5 volt. Okay, but whenever the capacitor reaches 0 volt, it will stop charging, because your next cycle will start again at your next cycle will start again at 400 microsecond. That means this is 200 and next 200. Okay, so like this. So plus 5, it will give you 0 volt. So the capacitor will charge like 0 to 5, minus 5, then again 0, then again minus 5, and it will continue 0, minus 5, like this. Okay, so you are getting a triangular wave. So what is your input? I will just draw it here. So I will just draw it here. Okay, so I will just draw it here. So my input was from minus 2.5, it is going to plus 2.5. Then after 200 microsecond, my input is going to minus 2.5. Then again it will stay there for 200 microsecond. Then it will go to 2.5. Okay, so that's why the output will be going. So this is the input. So my output will be going like, start from 0 volt, goes down to minus 5, then again it goes to 0 volt, goes down to minus 5. So this is the output. Okay, so this is the output. Okay, I hope it is clear to you. Okay, next we are going to discuss about another kind of circuit which is known as the differentiator. Differentiator. That means you will be getting the differential of a voltage at the output. Okay, so the circuit diagram is that you will be having something like this. Okay, and in the integrator you had the capacitor here, but here you will be having the resistance. Okay, this is RF or R you can say. Okay, then you have a capacitor here, and this is the C, and this is the input. Okay, now we will do the same kind of circuit analysis. Anyway, before that, so this circuit is the differentiator, and you will give some V in and you will get some V out. V out is equal to some constant. That constant will depend upon R and C. Okay, some constant. Okay, I will just write constant itself. Some constant multiplied with dV in of t by dt. So this is the output V out of t. So you will be getting the output like this. That means some constant into d differential of input, and this constant will depend on R, F and C. So we will see how to analyze this circuit. Okay, so differentiator circuit analysis. Now you have minus, plus, and this is your ground point, and you will connect the C here, and you have some RF, and this is your V out, and this is V in of t, and this is V out of t. Okay, now you know that this point is 0 volt because this is ground point, so this is also 0 volt. Okay, now I can assume that all the currents are moving away, I1, I2 and I3. So what is I1? I1 plus I2 plus I3 is equal to 0. Now I will write the equation for I1. What is I1? I1 is the current flowing in this direction, I am saying. So the voltage is at the point, let's say this point the voltage is VA, and at this point the voltage is VB. So the current is equal to Q is equal to CV, so C into D by dt of the voltage across the capacitor, right? And what is this? C into D by dt. The voltage across the capacitor is nothing but VA minus VB, because I am assuming that the current is flowing like this. So this is C into D by dt of what is 0 minus V in of t, because of my assumption. Okay, so this is nothing but minus C into D V in of t by dt. So my I know now, my I is I1 is minus C into dV in of t by dt, right, plus I2 is 0 plus, and I3 is 0 minus V out of t divided by RF. So I can find this is equal to 0. So I can find this V out of t by RF is equal to minus C into dV in of t by dt. Okay, so I can write my V out as V out of t is equal to, you can just move this RF here, so you will get minus RF into C, that is the time constant anyway, into d by dt of V in of t. So you can see that now I have told about a constant. Now your constant is depending upon R and C. What is that constant? It is minus RF into C. So V out of t is equal to some constant multiplied with dV in of t divided by dt. So the output is depending on the differential of the input. So I am going to write this equation. V out of t is equal to minus RF into C into dV in of t by dt. So the output is the differential of input. Okay, that's it. Now if you give a voltage, for example, if you give a suppose you give an input voltage as DC. If you give a DC voltage, then what is V out? V out is equal to minus RF into C into d by dt of the DC voltage, right? DC voltage is a constant, then this part become 0, so the output become minus of RF into C multiplied with 0, which is equal to 0. So now, so this is one example. Now another, if you give your V in of t as some voltage A into t, that means you are giving a ramp voltage like this. Then this is t and this is A into t. Okay, this is your V in of t. Now your V out of t is equal to minus of RF into C into d by dt into AT. So this is nothing but minus of RF into C. This is a constant multiplied with A. So this become a DC, right? This is a constant, again another constant. This is another constant. So this is the, if this is the input, your V out of t will be something like this. So this become A. So this is your V out and this is the time. So this is what happening. If you are giving an input like this, you will get the output like this. Now we will see a problem, then it will be clear to you. So determine the output voltage of an ideal op-amp differentiator in figure below. Okay, so you have an op-amp differentiator like this, and resistor RF is given here, which is 2.2 kilo ohm, and you have an output V out, and this end is grounded, and you have a capacitor C, which is equal to 0.001 microfarad, and this is your V in. Okay, now we want to find what is the output of this. Now what is the output? Actually, before that I will give the input also. Your input is a ramp signal like this. It is changing from minus 5 volt to 5 volt within 5 microsecond. This duration is 5 microsecond. Then again it is going down. Okay, then this is nothing but 10 microsecond. Okay, 10 microsecond, again going up like this. So this is 5 microsecond, then 10 microsecond. So the duration is actually 5 microseconds. So this is your V in of t. Now you want to find the output. So for this problem, I will give the answer now. Okay, what is this? Is a differentiator circuit. So V out of t is equal to minus of RF into C into d V in of t by dt. But what is the rate of change of input? You can write this equation for this line and also solve it. But it is very clear that the rate of change of input is nothing but, we know from graph that what is dV in of t by dt is nothing but delta V in of t divided by delta t, right? So this is nothing but what is the change in the output, because it is coming from minus 5 and the maximum value is plus 5. So maximum value minus minimum value, okay, divided by delta t. And what is delta t? It is happening in 5 microsecond. So 5 microsecond. So this much volt. So this is nothing but 10 volt divided by 5 microsecond. Okay, now I will get delta V in of t by delta t is equal to, it is nothing but 10 by 5 is 2 volt per microsecond. So this is the slope. Actually this is basically the slope of this. Also this is nothing but the slope of this curve, slope of that curve. It is giving the slope of this curve. Okay, and this is your okay. So this is nothing but the slope of this curve. Sorry, I will write, this is the slope of this curve. If you calculate the slope of this curve, you will get it anyway. If you, okay, that's it. Now what is V out of t? Now we know that the V out of t is equal to minus of V in of t minus of Rf into C into dV in of t by dt. Now you know what is this number. Actually this is nothing but 2 volt per microsecond, and this is nothing but minus of Rf into C multiplied with 2 volt per microsecond, and this is nothing but minus of, what is Rf? Rf, you know, it is 2.2 kilo ohm. So minus of 2.2 kilo ohm multiplied with C. What is C? C is 0.001 microfarad, and into 2 volt per microsecond. Okay, so what is the unit of this Rf into C? What is the unit of this Rf into C? So this you will get, this part you will get it as minus of, okay, you will get it as minus of 2.2 microsecond. Why I am using microsecond? Because this is a time constant. This is a time constant. So it is the unit having seconds. So if you multiply these numbers, you will get 2.2 micro. Then you just add second also into 2 volt per microsecond. So you will get it as minus 4.4 volt. So what is happening here now? You got the answer as minus 4.4 volt. This is a constant anyway, some number. So what I am saying, you know that when the input is changing like this from minus 5 volt to 5 volt, this is a maximum, in 5 microseconds, the output, so this is a V in, the output is negative, because you see here that your input is actually given to the inverting terminal. So when you give a positive input, you will get a negative output. When you give a negative input, you will get a positive output. But you see here that what is the slope of this curve? The slope of this curve is positive. So that means it is increasing. You are giving a positive input. That is the slope of this curve. If the slope of the curve is positive, you will get an output negative. Why you are getting negative? Because you are giving the input to the negative terminal. Now if the slope of the curve is negative, like here, then you will get a positive output. So it will depend upon the slope of the curve. So here the slope is positive, so the output is minus 4.4. So it is something like this. Now that's it. Now what is happening here? Now output is input is decreasing to minus 5. Now you see the slope of this curve, is the slope of this curve is negative. It is decreasing. So what is the output you can expect? V out is equal to minus Rf into C into delta V out by delta T. And what is this delta V out by delta T? It is minus Rf into C multiplied with, what is delta V out by delta C? Delta V out by delta C means, what is the final point? The final point is minus 5 minus the initial point is 5 divided by 5 microseconds. So you will get this as minus Rf into C into minus 10 volt, that is into multiplied with minus 10 volt per 5 microsecond. So the answer you will get it as 4.4 volt. That means you will get a positive number anyway. Okay, so I will write the answers here anyway. I will write the answer here. Okay, that's it. So this is 4.4 volt. So the answer for this is V out of t is equal to 4.4. So you see here that when the slope is positive, the output is negative, and when the slope is negative, that means it is decreasing, the output is positive. So this is what happening in this kind of circuit. It is because you see here the input is connected to the inverting terminal. Okay, that's why. So I hope this problem is clear to you. Okay, thank you.